Hello, this is Shari Kraber. Welcome to What's New in Design Expert Software version 12. It's good to have you with me today. A couple of administrative things. First of all, the slides for this webinar are available on the webinars page of the StatEase website. When we are done with this webinar, we will post a recording of it that will also be available on the webinars page. If you submit questions through GoToWebinar, I will respond to those questions via email after the webinar is done. So let's get started. This is going to be a brief overview of the new features of Design Expert version 12. We have a couple of new statistical features that I think you'll find interesting. And then, as always, we have some of our favorite new user interface features that I'll demonstrate for you. So we are going to start this morning with logistic regression. And logistic regression is a tool that is used when you have binary responses. Now, binary responses can have two states. Often it's thought of as pass-fail data, or it might be a survival versus death failure in a life sciences type of system. Logistic regression is the appropriate regression analysis for this type of binary response where you can only have two states. Basically, it's measuring the probability or the odds of the response taking on a particular value, and it's modeled as a function of the input variables. When you have the typical ANOVA analysis, but you also have a binomial response, we are violating the normality and constant variance assumptions that ANOVA requires. And so this is why you need a different type of regression analysis. So logistic regression recognizes these boundaries of the proportion and is definitely designed to handle binary responses. I'm going to demo this just briefly. Since the slides are available to you, I also included in that slide deck a couple of background slides. I'm not going to go through them here, but they're available for you if you want to dig a little deeper into the math behind regression, logistic regression. So the little case that we're looking at this morning comes from Montgomery. He presents the test firing results for 25 surface-to-air missiles. They were aimed at targets that were flying varying speeds in a range from 200 to 500 knots. And the results were either a hit or a miss. So let's just pretend that you are in an airplane flying over this surface-to-air missile installation. How fast do you need to fly to reduce your chances of being shot down to an acceptable probability? Now, the details behind this example are going to be given in Martin's November webinar on logistic regression. So sign up for that, and he will also provide a lot of tips for running experiments with binary data. I am just going to present some screenshots and show you what it looks like in the software. So here's the data set. For instance, run 1, we are flying our airplane at 400 knots, and the missile misses us. Yay. In run 2, we are flying at 220 knots, and the probability of the missile hitting us is a 1. It hits. The nice thing about Design Expert is it is going to automatically detect the binary response and default to logistic regression. It will actually detect, here we have 1s and 0s. If you have 5 and a 10, it will also detect that, any binary response. In Design Expert, you're going to find this on the transformation screen. So you can see here I put a red box around the logistic regression that will turn on by default when we detect the binary data. And you can choose your success level if you want that to be, which value you want that to be. We have it set here to be 1 right now. We run a pseudo ANOVA. This is on the ANOVA tab, but it's not actually ANOVA, it's Logistic Regression. This is based on some chi-squared testing, and you may not be familiar with that, but you should be familiar with the translation into p-values. So we give you the p-values for the factors, and we also provide some pseudo r-squared values. So again, traditional r-squareds can't be calculated, but there are some substitutes that have been developed for logistic regression. So we provide that information. Diagnostics are also a little bit different. We don't have all the diagnostics that you have for analysis of variance, but we do have some. So we have residuals versus predicted, residuals versus run. We have a Cook's distance, predicted versus actual. So these are common diagnostics that you should be used to seeing from the rest of the analyses that you do. Finally, you get to the logistic regression model graph, which looks like this. Across the x-axis, you can see our speed ranging from 200 to 500 knots, and the y-axis is your probability, in this case, of a hit or a miss. So interpreting this, if you look in the upper left-hand corner of the graph, you can see that we are flying at slow speeds, 200 to 300 knots, and the probability of being hit is very high. On the lower right-hand corner of the graph, when we're operating more in the 400 to 500 knot range, the probability of being hit is very, very low. So these graphics will appear whenever you do a logistic regression analysis, and hopefully with your subject matter knowledge of the system, you'll be able to interpret them appropriately. So that's the first statistical tool that we've implemented into Design Expert 12. The next tool is for those of you who are doing formulation studies, and you also have to combine process factors, making this a combined mixture process study. There are new models developed by Scott Kowalski, John Cornell, and Jeff Vining that reduce the number of runs. So the systems are combined. On the left side here, I have just representing a process system, which is generally represented as a square or a cube system. And we have to combine that with the mixture, which is generally some simplex triangular in shape. So we get two separate models from these. In this diagram, I'm putting together 3 mixture components with 2 process factors. So the mixture model consists of 6 coefficients, and the process model consists of 4 coefficients, the 2 main effects and 1 interaction. If we cross those models, 6 times 4 is 24. So you are going to be required to have a minimum of 24 runs to fit those 24 coefficients. Plus, as always, we have some replicates. Okay, so the traditional crossed model is used to model the dependence of the mixture formulation on the process settings and vice versa. So for instance, if you are mixing up a cake batter, you also need to bake the cake, and so you might have time and temperature involved. We want to model the dependence of the cake formulation with the time and temperature settings. So we do this by crossing the models. The crossed models end up having a lot of terms, and so some people have suggested perhaps an additive model is a simpler way to go. And while it's true that additive models have fewer coefficients, it sacrifices the ability to model the dependence of the mixture and the process factors on one another. So it is just like you are running two separate experiments. You are just adding the components together and not combining them. So the pros and cons here: the crossed model, which is our traditional model in Design Expert, completely links the mixture components and the process factors, but requires a lot of coefficients. The alternative additive model is certainly smaller, but does not provide any linkage, and then you might as well do separate designs. So the question was, is there a compromise model? And that's what Kowalski, Cornell, and Vining have proposed. In their approach, the linear parts of these models are crossed, and the higher order terms are then added to the crossed linear models. So you start by crossing the linear model for the mixture with the main effects for the process variables, and then you add the second order terms. As an example, if we have our three mixture components and true process factors, the quadratic by quadratic model is represented here. The mixture portion would have 6 possible terms, coefficients, and the process factor also has 6 coefficients. If you crossed them completely, you would have 36 terms in the combined model, but the KCV model, with only crossing the linear terms, ends up having 15 terms. So this, in essence, is reducing the number of runs required for combined designs, which I'm hopeful will allow a lot more people to use combined designs, which are really, really valuable in formulation work. The implementation of this in Design Expert is simple in that when you're building your optimal design and you are choosing the order for your design, you can now choose KCV model. I've got that highlighted in red here. So once you choose the KCV model, the software will know to cross the linear terms and add the higher order terms. I've made up a little chart here showing the number of runs reduction. As an example, if you have 4 mixture components combined with 2 process factors, the crossed quadratic by quadratic design would be 60 runs or 60 coefficients, whereas a KCV model would only be 21 coefficients. That is a reduction of 2/3, and yet we have empirically found by testing this that the modeling that we get from the KCV model does the job. I mean, it doesn't model real super high order complex interactions, but by just crossing the linear portions of these models, we definitely discover the dependences, the interdependences between these two types of variables, and it definitely does the job for us. So there is a question: is the KCV model the same as cutting the full model above second order terms? It's not the same, because the full model would have a lot of crossed terms even at the higher level stage. So the KCV is only crossing the linear terms and then adding the higher level terms. So yes, we have been teaching our students in class to do this by hand. This is something that you could do by hand in the software previously. Now we've just added it as an extra feature, so it's much easier to use. All right, let's move on to a couple of the user interface improvements. We have some additions in the graph columns option, and then I will bring up the a a case study and show you some of the other new views that are available. So first I'm going to show you the graph columns. I'm just going to grab a historical data set, and I'm going to go to graph columns, and one of the new views is the ability to display a histogram of the data. And another view is a 3D scatter plot of the data. So you can choose which variables or responses you want to be on the various axes. You can color them by row status or by any of the other columns that you want and create a new look. So both of these were requested by our users, and so we're happy to be able to use those now. Okay, so at this point I'm actually going to pull up Design Expert. I have a simple two-level factorial design. One of the difficulties of analyzing factorial designs is that the advanced regression tools that work so well with response surface designs don't work well when you have just two levels for a factor. So we rely instead on graphical tools. So if you've done factorial designs, you're familiar with the half-normal plot of effects. In DX12, we are now displaying the half-normal plot and the Pareto chart simultaneously on screen. I mean, why not use the wide screens that we have at our desks now, or just try to use the real estate better? And as has always been the case, when you choose things on the half-normal plot, those same selections are reflected on the Pareto chart. So you can work with both of them at the same time. We are hoping that this makes it just easier and easier for people to choose the significant effects and leave the non-significant ones in error. All right. If you've been using Design Expert 11, then you are familiar with the diagnostics, the 4-pane view of diagnostics, which I find to be really convenient to give me a very quick view of the diagnostics, reducing the amount of time that I spend on them, but always checking your diagnostics, especially looking for outliers, using the Spock-Cox plot for transformation detection. Okay, so there's this continues to be the same, but what we have added is in the model graphs view, we have added the ability to view multiple graphs on screen at the same time. So if you'll notice, there is a new plus button up where we have all the views, the view options. The plus button, if you hover over it, says add new graph. And so I'm going to click on it, and then I can add another graph. I'm going to choose to add another interaction graph since I know that in this design there are 2 interactions. So I can view both interactions at the same time, and I could move any of these other factors if there was a third thing. There we go. A is also in the model, so when I move A, it affects the CD graph. Okay, I'm going to add 2 more. I'm going to add 2 3D surface graphs. And I'm going to set the lower left graph to be AD to match the upper graph. And so now I can get both the interaction graphs and the 3D surface graphs all in one view. So this is just a nice way of visually displaying it. You can do a screenshot of this and put it into your report. The other thing that we've done is these legends are now all dockable and movable. You'll notice that there's this little box with the arrow in it near the legend. If you right-click on that, you can choose an option to show and hide legend items. So I could take off some of this information if I wanted to reduce it. I could undock the legend and then be able to move it. And I can also dock it at any location that I want. So I can make the software put it in a more convenient location. So we've just tried to give you some increased control over all the features that are already on the screen. Okay. As I said, the slides are available for you in the on the website. The last thing that I'm just going to mention very briefly is that we have added additional categoric codings. Some people have asked for additional coding options. So we have some additional categoric contrasts that are available. You will find them by right-clicking on your factor column header and going to Edit Info. And then you can get a pull-down list that allows you to choose from various options. The default is the sum option. And I'm not going to explain all of these here because I think it's a lot of statistical detail that most of you don't want. But again, download the slides and you can read all these. The new one that I think is somewhat interesting is the treatment coding, where you can set one method, one particular level to be your control lot, and then all the other levels are compared to that control lot. So of any of the new features, I think this is the one that could be useful for some situations. There's something called Helmert coding, and there's our ordinal coding that we had before. And finally, there is the ability to do custom coding. So you can code the contrast in any way that you would want that fits your needs. All right, so that is the list of the few statistical tools that we have added and the user interface tools. What's next? Well, we have the November webinar on logistic regression coming up. So if you go to our webinars page, you can sign up for that right now. You can also watch previously recorded webinars that are on our website. I'm going to show you some favorite topics on the next slide. And I also want to remind you that we have public workshops. We just published our 2020 workshop schedule. We will be out in California. We can also come on site. So we do on-site classes all over the United States and also all over the world. If you are willing to bring us on site, we are happy to come. So here are a few of our pre-recorded webinars you might be interested in. We have webinars that talk about power and precision, some multilinear constraints, tolerance analysis, propagation of error, and a couple on optimization, including how to use CPK and PPK, and also using confidence intervals, prediction intervals, and tolerance intervals to frame your operating space. So I encourage you to download those webinars, watch them, and see what else you can do with Design Expert software. It's a very powerful tool, and I think most people are only using a small percentage of what it can actually do. With that, I'm going to conclude this webinar, and I want to thank you for your time and attention today, and wish all of you the very best for the rest of your day and this beautiful upcoming weekend. Thank you very much for attending, and send us your questions as you have them. Good luck with your experimenting. Bye-bye.